Now that we have the model running, let's actually look into the code. So how are those services built? We especially look at two services, the gateway service to connect the model to the service with the callbacks, and we have a look at the control logic that actually implements the game logic. So I already opened Eclipse here. In the top left, it's probably too small to read, but it cannot be increased here. What we have are different packages. So we have the board gateway package, which is the gateway service. We have the game control package, which is which contains the service for the game control, and we have the other services also and some helper methods. You can have a look in the handout to see what those contain. You can have a look at it, but you only have to focus at those two, the gateway and the game control logic. And each of those packages always contains two classes. One is the main class, which contains, well, the main method and is responsible for wiring everything together. So what it does is it creates a connector to the VSL, it registers it as a service using the certificate, and it wires the nodes together with a service using subscriptions and virtual nodes. And the second class is the handler class that always exists, and the handler class basically just contains the actual logic of the service. And for example, if you receive a callback from a virtual node or subscriptions, you can call the according method in the handler class, or you can have some background thread running there like we do it for the game logic. It continuously checks some state and acts accordingly, for example, controls the smart device. Okay, so what your task here is that this code is incomplete. So in the board gateway.java class, which we can see here, we have two to-dos for you. So they are always mapped, described in that manner. So you have a to-do number one, which is that block. We have some description, okay, what should happen in here, some hints on how you can complete it. And then here in that free space, basically you should put your solution into it. So it might need more lines or less. And in this case, you have to implement the missing subscriptions and their handlers. And you can have a look at examples above here. So you can add a new subscription by calling connector.subscribe, then give the address that you want to subscribe to. That symbol means relative to the root node to the own node. So it's basically if this is /ka1/ board for the gateway, then this would be equivalent to /ka1/board. And then the subnode player 2 green is on desired. And then you add a new VSL subscriber, which has one method as internal method, so the notification callback. So whenever this value is changed of that address, this method is called. And here you just call the handler.setValue address, give it a method, give it the address that was changed, and the path on the IoT device, the core path that should be updated. So you can have a look at the examples and description to learn more about that. And then later you do the same, or below you do the same for the virtual nodes. There are also 3 virtual nodes missing. Idea here is that virtual nodes, we implement the GET requests like here. And that means whenever a node that's registered as virtual is requested via GET, the method here is called, so we can directly get the value from the IoT device, for example, and only then return that value. So you can get the live update from the IoT device. Second thing to change when you're done with that is the game control service handler here, which implements the game logic. And what we have here is a background thread. So here we schedule it with a delay. If you look at the bottom, you see it's running every 500 milliseconds, I think. And then we have a run method, and in there we implement the logic. And you can just follow the instructions here. So the first to do would be using the type search to check the gateway is actually running, because we need the gateway to access the IoT device. And if that one is not running and not found, we can just stop right here. So if the address of the gateway is null, we return, and your task here is to include the check or search for addresses of that gateway service. And if you find it, you can assign it to that board address and continue with the logic. The next step would be to, what we already do here, get the state from both players. So is there a button pressed? And only continue if this is the case. Then in this to-do, you have to prepare the device for the game. So you do connector operations to set the LEDs to on, for example, and set the alarm to on. You can just follow the description. And then you have to trigger the first player, trigger the second player by setting the trigger node. And then last but not least, we continue, we calculate the winners. You can have a look at that. When going through it, we blink the LEDs to indicate who is the winner. And one more thing I want to show you is when you do set or get operations to the VSL, in this case, for example, for get, you can always use the connector.set address and value, where value is a VSL node. And that just sets the value, or you call the helper method set and report with the same parameters. And what this does is it just calls the, in this case set, or by get and report the get method, calls that method, but also measures how much time is from before issuing the operation until it returns, and then reports that to the monitor service that we saw. So that means if you use that method, that call will be reported to monitor service and is visible in Thunderbird, in Firefox, sorry. Good, so once you're finished with implementing the code, you can again start everything. So you start one knowledge agent, the agent 1. You start the IoT device. You can do that from the finished jars, from the binary for the tutorial bin directory. You can start the monitor service and the leaderboard service. And then you have to start the gateway and the service. In this case, you can just do it from Eclipse. You just right-click on the main class, so board gateway, right-click, run as Java application. So I won't do it now because I don't have a knowledge agent running. If you do that, the service is starting here. And if you want to stop it, there will be here in the bottom right, there will be a red rectangle that you can press to stop the service here in Eclipse. And you can do the same for game control. So when everything is running, the game should be playable using the IoT device. Good, now have fun with trying it out on your own.